Data is complex and chaotic, and as in life, we all know that it can be quite chaotic as well. As a father of 6 daughters, I know chaos, yes, quite well. And so the question that I always get when everybody goes, 6 daughters, like you did, sir, is, what were you thinking? And so sometimes I'll explain it, and sometimes I won't. But in order to make the point in this presentation, I'll give you a brief history of my life, my personal life, about how I got to 6 daughters. And the key point being is that when you have 6 kids, managing those conversations, making sense out of it, in order to be a good parent, is really, really difficult. So it's complex and it's chaotic. So how do you tame that? So let's go back 20 years. Me being single, as most of you were probably single in your 20s, and go back and life's simple. All you got to do is manage yourself, which as a 20-year-old can be quite a challenge as well. But at some point, I met my future wife, and we decided that, as most couples would, that we wanted to spend our lives together, build a family. But you start with pets. So we added a cat, Bean. Then we added another cat, aptly named Kitty. And then after having our practice rounds with our cats, we decided that it was time to have a child. And so from my first daughter, Olivia, was born. Olivia grew up a little bit, but at that time, one of our cats died, Bean. So unfortunately, we had the addition and subtraction. Had another daughter, Peyton. And then added yet another daughter, Roxanne. At this point, you start questioning yourself, right? Now you're outnumbered, and why am I doing this internally? At this point, one of the cats opted out again. It left the house. Didn't find it, so don't know if it's truly dead, but it gets the X anyway. And then added another daughter, Tallulah. So Tallulah, fantastic. Awesome little blonde kid. Doesn't look anything like me. And then a 5th one, which was not planned. So now I have 5 daughters, and at this point, I'm done. But as a parent of 5 daughters and having a wife, that means you focus a lot on your kids, and it's really, really challenging to be together as a couple. So unfortunately, that didn't work out. So we split up, family separated, and as time went along, I met my current partner, Kim, and she has 2 dogs, Kibo and Denali. So we decided, after many long conversations, would it make sense for us to continue? And we did, and so added to the family. So now we have 2 dogs, Kim, an ex-spouse, and 5 wonderful daughters. Well, unfortunately, one of the dogs exited as well, which I am not the biggest pet lover, so there's no sympathy in my mind. So I apologize to the pet lovers in the crowd. And then I had another child, and I was not really expecting this one. So after being divorced and having 5 children and then having another child, fantastic. So Zoe. So now I have 6 daughters, and you can imagine the chaos that comes with 6 daughters. You have 5, so you know. So how do you manage this? One kid talks to you, it's easy to have a one-on-one conversation. 2 kids get going, the noise starts ramping up. But you can sort of multitask that. 3rd kid gets going, it becomes challenging. Now you're just trying to avoid noise at any cost. But what happens when one kid starts getting pissed off? Now you don't know. Now all these kids are talking, but you don't know if someone bit someone and that's an actual real thing, or if they just want to go outside and play. Now imagine this. Right? This is complex. And so as a parent, you're supposed to actually listen to your children. So there's nothing like your child coming up to you and saying, "Hey, Dad, can you put the cell phone down, please?" So you actually pay attention to them. But there's no actual way to manage these conversations if they're all talking. So as a parent, what do you do, right? You try to prioritize, you try to listen, you try to remember prior conversation, you try to equate those to current conversations. But if I had technology that I could apply over this entire situation and solve it from a technical perspective, this is how a potential way you could do it. So a queue, right? All these messages come in, all these kids are talking, but if you could actually serialize them, line them up, and they come up and say, hey, Dad, I'm bored. Hey, Dad, I'm hungry. Then you can actually process that message. But the problem with this is, in this case, in all these serialized messages, you've got a kid in the back that has one really big message. I've got to go to the bathroom. But you want that at the front of the queue, but you can't when you serialize it. But there's a better way to do it. So that better way is to take the queue, add in logic that processes that real-time stream, accesses your memory of historical conversations, and then apply that. And then you can actually weed out some of the conversations that aren't meaningful and bring in the ones that are and actually apply them. So my daughter, Olivia, who's now 14 years old and is starting to get in boys, prior conversations. I met this guy, Jake, and I've been Skyping with him. I have a conversation. It's midnight, you need to get off your laptop, no more Skyping with Jake. Conversations are coming in. Dad, I'm bored. Dad, can I play Minecraft? Dad, hey Dad, hey Dad, hey Dad. And then Olivia comes up and she's like, hey Dad, I'd like to go out and meet with my friends. Out of context, that's nothing, right? That's not a problem. Okay, go ahead. But remembering that she said, I met this new guy, Jake. I've been Skyping with him. I've told her to get off the phone. That suddenly becomes an important conversation as a parent, right? So you prioritize that. So if I had the ability to do this, which I don't, I do this very poorly, then I would be able to solve these challenges and actually pay attention and take the important conversations. The cool thing with all of this, though, is we can apply this. So at Avalon Consulting LLC, we're a platinum sponsor here. We've been around for 14 years, and we're a systems integrator. We focus on enterprise content management, enterprise search, and big data solutions. And what we're talking about today are big data challenges. So what we do to help people is lots of times they have boxes. Those boxes need to be connected to other boxes, so we make that connection. So what we took that conversation of me managing my kids and the inability to do that, but we can do that in real life. So a real life case scenario is marketing and web clickstream analytics. You have a website, you have all this information coming in, you want to be able to process it, you want to be able to give the right offer at the right time. So what we did was we built a demo using many technologies, which Andy's going to go into, that describes how these things work, where we can successfully engage and act on conversations in real time.
Can you hear me?
Yep.
Okay, cool. Thanks, Chad.
I actually don't know if you can hear me. Can you hear me? How about now? I can hear this. Can you hear me now? Yeah. I talk like this the whole time.
Thanks, Chad. With that, as chaotic as Chad's life is, this is actually very similar to how we receive data in a scenario like a website or the web world, right? It can go from 6 kids to 6,000 users, 600,000 users, 6 million users to a website. That gets really chaotic when you're starting to look at what people are clicking on, what are they doing on your site, and how do I act on that, right? So taking Chad's kind of fantasy technology he wishes he had in his head, we can actually apply this with real technology in the technical world. So starting with a queue, we need a way to be able to process all of our messages and process messages that are coming at us from all different directions, from all different actors, and all at the same time. Right? A queue is a great way to do that because it not only makes sure that we see every message, but it will only give us the messages as fast as we can actually process them. Right? You could hook up the fire hose to any old application. You may have to start dropping messages though when you get to a point where you can't process as much as coming in. So that's where we need a queue. And more specifically, that's where we need something like Kafka. Kafka is a really great publish-subscribe tool where it will queue our messages up for us and allow us to consume them as fast as we can, but save them for us so that we can eventually get to all of them and feel safe that we've gotten to all of them. Secondly is we need some type of historical basis. If Chad has to sit around with every conversation with his daughter, for example, Olivia, coming to say, Dad, I want to go hang out with some friends. Well, that's probably okay. Sure, go ahead. On the face value, that sounds great. But we need to know that yesterday she told us she was up until 12 o'clock on Skype with this boy Jake, And a few days ago, she told Chad that I really like this boy Jake and I'm hanging out with him all the time at school. Well, now going out with friends, unknown friends, may seem like something that Chad needs to say. Well, who are you going out with? Do I need to be worried? What time are you getting home, right? So we need to apply some type of historical basis to the data that we're processing. And so that's kind of where Couchbase comes in. Couchbase is a great distributed store, and we can use it to save all of our historical records and marry them with what's coming in right away and make logical decisions. And the last piece is in the middle there with our logic. So we need a processing engine, something to marry the two data, all of our historical data and all of our streaming data. We need a way to put those together, apply some logic, apply some rules, figure out, is Olivia going out with this boy or not? And for that, Spark is a really great tool, up and coming. Mixes great with Kafka for streaming, and also mixes great with Couchbase, not only for streaming, but also for some batch analytics. So let's look at how we can set that up. So it starts with Chad, here in the middle. After a long day of listening to conversations from all 6 of his daughters, processing should Olivia go out with this boy or not, he needs a beer. All right. So he's going to come to our website and browse some beer, maybe make some purchases. So what we're going to set our application up on is something like Node. And we're going to run a loopback framework in Node, very responsive framework with Angular JS in front, just to make everything responsive and interactive and look great. On the back end, we need somewhere to keep all of our data, right? And actually, we set up our beer store, our beer website, off of the first data set that you ever look at when you're working with Couchbase, and that's the beer sample that's built in, right? So Couchbase is actually going to provide us with a place where we can store all of our beer, all of our breweries, beer samples, and then all of our data that we're going to produce afterwards. At the node level, we're also going to track all of our events, right? It's a website. If you've ever thought about what data gets stored from you when you're actually on a website, it's kind of staggering, right? The website itself is storing the request that you made to it, the response that they gave you back, what you clicked on, all the interactions that you did on the website, how much time you spent there. All of that data is generated by you. You don't necessarily see it, but it goes into the back end with OWA tracking framework that we added to Node. Now, instead of just shoving all that data way back into Couchbase, we may need something like a data transport layer. And that being that not only can we process data as fast as Couchbase can take it in, which is pretty fast, that's not really the mainstay here, is to provide us with a way that we can access that data from multiple sources, not only Couchbase. So our tracking events go into a Kafka topic or a Kafka stream, right? From here, from Kafka, we can actually do anything with our data. We can set up as many consumers as we want to come grab that clickstream data. So we actually have 2 routes. One is to Couchbase. We want to store a good historical basis for our clickstreams so that today we can make decisions based off what our users were doing yesterday or the day before. We also want to send it to Spark. Spark has a really great streaming framework, and we can process data as it comes in and make actionable decisions right then and there and return it back. So while we're in Spark, we can not only take our clickstream data, but also marry it with a lot of our historical data in Couchbase and just profile data, what users have logged in as, all of the backend data for our beers, breweries, types and styles of beer, all of that. We can mix it all together, make some decisions, apply some rules and logic, and then send it back into Kafka to be consumed by whoever needs to consume that data. And the last step is Node takes that data back. We're going to take data like actions. What have users been doing that we need to be actionable on? So did someone look at 3 beers from the same brewery? Well, if they're having a hard time making that purchase buy, maybe we give them 10% off and say, hey, everything you buy from this brewery, sure, take 10% off. Maybe that will increase our ability to sell. And then we can also make some decisions like trending. What beers on the site have been looked at the most? Are our customers feeling particularly boozy? What's the average ABV in the last 30 minutes that people are looking at? Right? There could be some interesting things to look at. So all that stuff goes back into Node, and we can give that back to the user and show them that. And Chad is happy. Yeah. Okay. So we put all this together, and we can actually show you a demo. So let's go ahead and do that. Let's see. Very cool. So this is our beer store, aptly named beer store. It provides a lot of the same features that you'd expect out of most e-commerce sites, right? We've got some featured beers at this point sorted by how strong the ABV is. But this is all being powered by Node and using Nickel to look back into Couchbase and grab all of our data, right? With Nickel being so flexible, I mean almost about as flexible as you can get with SQL, we can do all the things that we want to do. We can list out beers by state. We can list out beers by the brewery they came from. Everything that you really want to do to power a website. So that's our first use for Couchbase here. All right. So this is running locally on my machine, so we actually need to simulate some more people clicking on some things so we can actually see some cool things going on. So I'm going to go ahead and run that right now. Sorry to show you all of this. Right on the right here, I'm just running a simple JMeter script to just produce a bunch of clicks on our site on beers. And then over here is a Kafka consumer that says these are all on the clickstream events that we're seeing, so we can see we're getting a lot of clickstream events. Okay, so kind of our first of 3 processing facets is trending data. We want to be able to say, or give to the users what kind of trends are happening on the website. Have a lot of people been looking at Alaskan IPA? Well, maybe I should be looking at Alaskan IPA, right? So up here in the top, we have a now trending. And if you remember back to our architecture, this trending information is kind of going in a circular feedback loop, right? It's being generated off clickstream in Spark and coming back to us. So this is actually updating in real time. It's dark star now, and we may see it change as the random clicks go through, but we can actually bump it. So if I go to look at Alaskan IPA, and I click here, I'm going to go back and I'm going to click on Alaskan IPA again, simulating a lot of people clicking on Alaskan IPA in quick succession. We should now be able to see that now trending is going to bump up to Alaskan IPA. Yep, there it is. So we can get some pretty good feedback loop back to the customer, right? So this is facet 1. Facet 2 is kind of on a more per user basis. So we want to track what users are doing individually, and if they're kind of doing things that are interesting to us, like looking at a lot of beers from one brewery, well, we want to be able to produce an actionable result. We want to say, let's help you out. You know, I'll give you a 10% discount for that brewery. So I'm going to start a new tab here to simulate a new user. So I like Alaskan Brewery. So I'll look at a few beers from Alaskan Brewing. And some logic we have in Spark is to say, you know, when 3 beers from the same brewery have been seen by the same user, let's give them back a message. So I've seen 1. So I'm going to go ahead and see 2. And then we'll finish with Alaskan ESB. And you see down here in the bottom, we have our 10% discount for Alaskan Brewery. And again, that's going through the same feedback loop of clickstream going to Kafka, Spark pulling that data from Kafka, marrying it with backend data from Couchbase, and sending it back after we've applied our rules. The third facet is more of a batch process. So we've mainly been doing kind of clickstream and stream processing. But Spark and Couchbase can also be used to do batch processing on historical data, right? So one thing that our app does is allows you to add things to cart and make kind of fake purchases, right? A very common use case in e-commerce and in a lot of different use cases is to look at patterns of what people are buying and what people are buying together, and then say, if you're buying this item, well, a lot of people also buy this second item that's in tangent, right? So let me see. I can start, let's find a beer that we can look at here. I chose this one because it doesn't have a full set of featured beers yet, and we can see it in real time. So this beer, Tokyo, has 4 also selected you may also like beers, right? What we're doing to create this also liked is a batch process in Spark. We're pulling all of our order data from Couchbase, running an algorithm to say what are all the common pairs, and then giving those back so that we can produce this list. And we can kind of do an example of how we can affect that and see that working by doing our own cart. So if I actually add Tokyo to cart and purchase it with a beer that's not already in our recommendations list, we should expect that the beer that I purchase it with should also come into recommendations, right? those two beers were bought together. So now we may want to tell someone else that those two beers were bought together, and maybe they'll find them the same interesting. So I added that to cart, and let's go grab a random beer here. Maybe Fort. All right. So I'm going to go ahead and make this purchase. And our batch process is not always happening like our streaming processes are. It's more of a manual process that you can run, or you can be told to run maybe every hour. Let's update our recommendations list, right? So I'm going to go ahead and do that now. This is just running a Spark query. It's going to take about 30 seconds. Not 30 seconds, 3 seconds, excuse me. Okay. So after running our recommendation algorithms in Spark, we should expect to be able to come back to Tokyo and see that the beer that we just purchased it with is now in the recommendations list. Fort, right there. So those are the three main ways that we can marry a data transport utility like Kafka and a processing engine like Spark, and then a highly distributed backend data store like Couchbase to provide very interactive and very interactive. I'm blanking on another word. Interactive application for users. So let's go back to here.
Can you guys hear me? Can you hear me? Nope. Nope. This one's okay? Okay, good. So, complex application. Takes a lot of work. We did this in about 2 weeks with 3 people, building all these pieces together. This is running on a Vagrant box on our local machine. We have the ability to scale this horizontally. It can take in, ultimately, millions and millions and millions of clicks and process them. So, wanted to open it up. It's a complex way of doing things. It may seem overly complex for what we're doing here, but these are real-life types of things that Avalon is presented with our customers. We have customers, how do you do clickstream analysis? So in order to facilitate that, we built a demo based on that. So wanted to open up to questions to see if anyone had any questions, and we can walk through them.
So once you kind of,
Do I need to pass the mic?
yeah, sure. Once you've kind of figured out what your standard queries are in Nickel, do you convert them to views for performance, or do you generally not do that?
So at this point, we get the beta, and we're using Loopback, and so Loopback has a built-in ORM, and there's a Loopback connector that connects into Couchbase. The current one that you pull down doesn't work. We had to manipulate it a little bit. We don't really compose the queries. We're just allowing the ORM layer to complete that. To build this app, we built the primary index using GSI so that it gets updated as we're adding more information, but bare bones simple. At a larger scale, we can definitely go ahead and create views and more indexes as needed to be more performant. Any other questions? No? Okay. Well, let's one final question. Who has kids? All right. Who has more than one? Who has more than 2? Who has more than 3? Who has more than 4? More than 5? Nope. All right. Unfortunately, I went again. All right. Thank you very much. Appreciate you guys coming out.